prestigious projects like Swiss Development Corporation, SDC, British High Commission, Indian Institute of Technology, Mumbai, Institute of Chartered Accountants in India, and many more. She is the co-founder and director of the New Materials Research Center at ISDI and has more than 5 years of teaching experience in master's programs for environmental architecture and 10 years overall teaching experience as visiting faculty to various architecture colleges in Mumbai. She has several completed works, and her ongoing works include 10 million square feet of residential works, 1 million square feet of commercial and interior works, 40 million square feet of studies on sustainability and high performance buildings, and has been awarded as a key contributor to the 3.2 billion green footprint in India. Thank you.
Yes, thank you, Shruti. Over to you, Meenal.
Thank you. Thank you, Shruti. Thank you, Parikshit. Thank you, Gaurish, and everybody, all our peers who are all my peers who are here. I'm just going to directly start with the screen share. Parikshit, can you see my screen?
Not yet.
Okay. Yeah. Okay, I got it. Can you see it now?
Yes. Yes. I mean.
Okay.
Yeah. Yeah.
All right. So welcome everybody. Welcome to this session on a very intriguing topic regarding sustainability in tall buildings. It's very ironical because, you know, the very word sustainability and the notion of tall buildings and urban scenarios is sometimes, you know, quite contradictory. It doesn't go hand in hand. And, you know, before we kickstart, this is the scenario that you've been talking about. I think these are the, you know, these are the scapes that you are designing by way of designing your individual buildings that I probably think you're going to take up in your design studio. These are the, you know, these are the environments that we are looking at, right? So when I say environment, I don't only mean the natural environment, right? As human beings, as designers, as architects, we are also creating a lot of man-made environments, correct? So having said that, I think it's very important that I kind of, you know, put out a certain framework to how we would like to have this dialogue, how we would like to have this discussion. So I thought it was very pertinent that, you know, we look at this entire 1 hour of sharing that we are going to have as a understanding of, you know, what is it that we want to do, right? Why is it that we want to do, and maybe to a certain extent even how. And as I think years pass by, and you know, the more and more I get involved in education, and I'm teaching a lot more than what I was teaching in the past, a substantial amount of my time. I feel so excited because I think this is the opportunity you get to actually question the why. You know, as a designer, as an architect, I think it's very important for you, before you plunge into designing what you want to design and how you want to design, it's extremely important you understand why you want to design that. This is something that, you know, is very fundamental to your design understanding, to your very intention of whatever you are about to undertake. Having said that, I'm going to take you through a quick journey and an evolution of tall buildings, high rises, skyscrapers, whatever you want to call them. I don't know if this has been covered for you or if this is kind of, you know, been done in the past, but I thought it's a good beginning for us, you know. So this started this journey of this typology of tall buildings. Of course, it's a very age-old journey. We can start with the pyramids, but I think that's too far away. And we are talking about occupied buildings, or we are talking about occupied built structures, right? So I'm going to begin with something that's a little more than 100+ years. This was on the left. What you see is what's called as the equitable building. This was one of the first. This was the tall building at that point in time. I'm talking about between 1830s and 1850s. These are called as the first generation of tall buildings. And why these became very significant is that this was the first time that um, you know uh, the vertical transportation, which means that elevators, Otis company actually revolutionized to be able to transport people up and down in a safe manner. It's not that they couldn't take people up and down. They've done it for the Eiffel Tower too. But this was the first time when it was they figured out how to do it in a safe manner, in a consistent manner, in a far more controlled understanding. And vertically, if you see the Eiffel Tower vertical transportation, you're moving on a slope. You're moving in a slanted fashion. That's not what we are looking at. So we were looking at a far more figured out way of doing that. And there was a series of buildings that came in, and as you can see, they are really tall, floor heights, etc. They are still made of load-bearing structure. The kind of openings that were there were controlled or understood from a load-bearing standpoint. And what you see to the right is, as these buildings started coming up, within the urban fabric of cities like New York, Chicago, a little bit in Europe, a little bit in London, what these buildings started doing is these buildings started casting, a lot of shadow on the urban fabric. So what you see to the right is what we call as, the zoning laws in New York were passed. The zoning laws in a lot of urban scenarios, urban cities, urban developments were passed at that point in time. And this is during the World War period, where, tall buildings were not allowed to come up straight as a box. And, they would need to come as a stepped or a staggered form. And that's where you can see the Chrysler or the Empire State Building in the background. This is another building that you can see. So this is a very typical, what we call as, the wedding cake skyscraper, or the wedding cake tall building typology. This is how slowly the form of the tall building started evolving. But you can still see we are still with a load-bearing structure. Probably in that, not in the case of the building that I showed you, but still, the Empire State Building was also a load-bearing structure for a long time. Having said that, when we come to the next, which is like maybe in the 1940s and 50s, and you start seeing this, what you see on the left, and this towering, revolutionized form of the building, where you stop seeing the traditional material of stone masonry or plastered walls, and you all of a sudden are seeing this new material that is glass and a lot of steel. And this is, of course, an after effect of substantial revolution that happened during the Industrial Revolution, which enabled us to take our buildings to the second level, right? To take our buildings to the next level. From there, I think what I can safely say is that we started looking at our tall buildings from the point of view of, we had to do transportation. We had to transport up. And what was it that we had to transport up? We had to transport up people, but then people wanted to live up there. So we had to transport up water. We had to transport up gas. We had to transport up electricity and basic other utilities. So everything that we were conveniently functioning from ground to 3 stories or 4 stories, now we had to figure to transport it really high up, at least 20-30 stories. And this I'm talking about in 1950s, 1940s, 1930s. And on the right hand side, what you see is that once you take somebody up, you have to bring them down too, right? So transporting down, so you have to transport people down, you have to transport waste down, you have to transport wastewater down, you have to make sure your electricity is in a loop, and some more utilities, which we'll get into a later stage. At the same time, while constantly maintaining the cycle or trying to understand this transportation cycle of what I would call as components in the building, right, of living and non-living components of the building, you had to make sure that the buildings were livable, that the spaces were livable, they were comfortable, they were safe, they were secure. There was substantial amount of social health, and there was substantial amount of psychological health that was maintained. So that is a little bit of a journey that, if I may tell you, that the tall building or the skyscraper as a typology took. Now, what happened in that meantime, when that journey happened, and this is a journey that I'm talking about, and very soon I'm going to show you a slide of what's called as the 5 generations of tall buildings from, a resource standpoint, especially energy standpoint. So what happened is, in this 130, 140 years of development that we kept looking at, we kept resolving one after the other our requirements. So we went up and we decided to live up on the 40th floor or the 30th floor, or we decided to work on the 30th floor. Well, we had to bring everything up along with us, right? And then because we were using things up on the 30th and 40th floor, we had to bring it down also. So we were constantly doing this cyclic understanding of figuring a way of constantly moving these components within our building, as a result of which our buildings obviously started becoming, what you see on the left is resource intensive, right? Energy consumption started going up, because it's not like physically man is not pulling himself up, right? And we had to use energy as our basic resource to do this transportation of living and non-living components. Than in a regular building. In a regular building, it would just, man would take himself up, and he would take his stuff up, right? He would take everything up, and everything else that had to come down would come down by gravity. But as against that, today it's all controlled by energy, and we started seeing that the energy consumption of the building started going up substantial. Now, why I've said XX times is because it can be as much as 2 to 10x or maybe more. It depends on what you have designed for or how you have designed. So, somewhere around 1970s, 1960s, probably 70s, early 70s, what people started realizing is that these building typologies have started consuming a lot of resource, they've started consuming a lot of energy. But it was needed, because, we decided to go and, create this kind of a new living model. Well, we had to facilitate it, we had to service it so that it is livable, right? It also started taking a lot of water. It started becoming very water intensive. And most important, it started becoming very material intensive. So material intensive, what we mean is that the amount of material that is required to accommodate the same number of people in low-rise buildings compared to a high-rise building was almost 8 times or more. Now, that being on one side, it was of course resource intensive. Look at the other side. What happened is it was very capital intensive. Land price, well, land price shot up. In the last 150 years, what's happened in the urban scenarios in major cities of the world, and it's consistently evolving. Technology and construction costs shot up, so it's at least 2.5 times and more. So minimum, at a bare minimum, if I begin, my tall building typology is at least 2.5 times more expensive, than creating a low-rise building, and more. It depends on what you are going to be doing. And operations costs. Now, once you go and live there, once you go and operate out of that tall building typology, what is beginning to happen is my operating cost, which is in terms of my energy, water, my systems, anything and everything I require to facilitate my being, B-E-I-N-G, when I say being, my being up there, as a verb, me being up there, started becoming anywhere from 3x to 4x and more. Sometimes it compounded substantially depending on how tall you want to go. So I'm talking to you from a relative tall of 20 stories to probably like 100 stories, So this is a story, this is a discussion, this is a dialogue that we're going to have for that sort of a tall building kind of scenario that began to happen. So all over the buildings, what happened is, because it was becoming so challenging, there were multiple problems that were evolving. There were multiple challenges that were evolving. What you see at the bottom is it started becoming more about the building development. Obviously, we started optimizing strategies, construction, facade, materials, energy, water. but there was something that missed out, and we'll go to that all the way at the end of the presentation. Sadly, I don't have enough time, otherwise I would have dealt with that also a lot more. But I will definitely touch upon it, is the fact that, it was about less about people, so we were too post that time, we were too focused in resolving the building. But what does the building do for the people, right? Why did we go up there? We went up for ourselves. But what resulted is probable social disconnects, probable isolations, sick building syndromes, unhealthy buildings, etc., etc. So this started becoming the premise of, a lot of, like, what you can see, the issues that I'm just showing to you, if you would like to see, is what you see on the left hand side is, the building height is 3-story to 50 stories, and the amount of energy consumed by these buildings. So you have multiple 3-story buildings, or you have one 50-story building, and that's the kind of energy consumption it would take. Okay. Likewise, operational energy, what you see on the right hand side is, uh, the amount of energy taken to operate a 50 plus building is much more than what you would operate a 20 or a 10-story building. Or if you want to look at it from tons of carbon dioxide, since many of you understand carbon dioxide emissions, tons of carbon dioxide per person per year. As you can see, again, a high rise is far more carbon intensive than anything else, right? So it can be seen, that that's the correlation between height and, a lot of these issues which are coming up. Okay. Now, just having said that, there's some disturbance, Parikshit.
Yeah, I'll just check. I'll just.
Okay, I'm going to continue. You can just take a look at that. So what is happening is, yeah.
Shruti, I think your Shruti, your mic is on. Can you?
Shruti? Okay, I'll continue. So what we are seeing is, what happened from that first generation to fifth generation of buildings. And I just told you a general account, but what exactly happened during that evolution is a small mapping that I would like to show you. So the first generation was the equitable kind of generation that you see on the left-hand side, the equitable building, the Chicago, and many such buildings that, you see what we call as our heritage buildings across the world, many of you who may have traveled. So these buildings obviously were built more like load-bearing construction. So the good part is they had substantial amount of what we call as thermal mass. In other words, they're thick walls. So they could resist the cold of that climate type. Okay, these buildings were in a climate type that could resist the cold. Even if they were in a hotter part of the world, they could resist the heat. So the plus point is that it could resist the cold or the heat. They had shallow floor plates. Why? Because this was also a time when we had very sparing use of electricity, or we had just barely begun to understand how to use electricity. So imagine we didn't have electricity as energy, and yet we dared to go tall. I'm sure we understood a lot of laws of physics and a lot of basic understanding there. But the floor plates were shallow. Why were the floor plates shallow? In other words, what we are trying to say is the depth of the floor plate was not very big. As you can see here also, the width of the building is the depth of the floor plate. This is so that there is enough natural light penetrated. Okay. And this is a time when artificial lighting was also not so developed, or it was just invented, and we were still figuring out, we were still relying on natural light to substantially light our buildings. We still relied on our openings, for light and ventilation. However, these kind of typologies, they cast substantial shadows to the urban fabric, especially because the rest of the fabric was a very low-rise fabric. And of course, we had the advancement of the vertical transportation. Having said that, you come to the second generation, which I had shown you about, the Empire State, is, it still had a substantial amount of thermal mass, which means that it was still resistant to extreme cold and, extreme heat, or at least difficult temperatures, be it cold or hot temperatures. And the Industrial Revolution did bring in glass, steel, alloys, and more materials, and that's what you can see in these buildings as they are evolving. Light and ventilation was still a primary concern. They were not entirely optimized. Zoning laws, as you can see, were introduced, and because of which the a specific shape which is called as a wedding cake skyscraper started emerging across the United States and bits and parts of Europe. You can just Google it anytime you want, wedding cake skyscraper, and you know what I'm talking about. Now, by the time we came to the third generation, something happened is we got this curtain glazing, which reduced the weight of the building substantially, obviously because the heavy wall material went away. We had glass and we had aluminum and we had steel that was used, not aluminum, steel at that time, as your major framing, external facade that was used. So thermal mass disappeared. So the good thing is the building became lighter. Okay, the building started getting a lot more glass. So people were happy that, oh, a lot more light. But what happened is the thermal mass disappeared, which means no resistance to heat or cold. So in winters, the building would get very cold. In summers, the buildings would get very hot because they essentially started becoming glass boxes. So the light was slightly better in areas where they don't have very harsh light, but these started becoming symbols of prosperity across the world, and you start seeing these towers all across the world. You see them in Tokyo, you see them in the US, you see them in London, you see them somewhere in Germany. Irrespective of climate type, they started coming. And why I'm saying light is better, because they started working with a very dark glazing. So one of the first examples of that was the Sears Towers and Mies van der Rohe. I'm sure you've studied him. And he wanted to use a darker glass to absorb more heat because they have more issues of cold days than hot days. So he wanted a darker glass to absorb that light, but and absorb more and more so that the buildings don't feel as cold as they did. And so this black typology became copied without understanding why it was used in the first place. So these glass boxes started becoming, very heavy on energy because they started having a lot of heat loss. There was no resistance to temperature. So their heating requirement went up, their cooling requirement went up, and substantial energy intensiveness that came through. And this generation of skyscrapers lasted for almost 2 decades, But what you see as the fourth generation, what I'm showing you here is when in 1970s, early 1970s, it's called as the oil embargo. And maybe you want to take a look at that. What happened, at that time and in the world, there was an oil crisis that happened, and US also faced that oil crisis, and because of that, everybody started getting concerned about how they are going to sustain. So energy was not available, and energy that was available was not cheap. So one is the resource reduced, and the second is that the capex on the resource, or it started getting more expensive. So people realized that they really need to conserve energy. They really need to reduce their consumptions. That became a primary goal, and efficiency started building in. So, the fun part is you'll see these efficiencies not only in building, you'll see them in cars, and you'll see in everything that had oil as its base fuel or as its energy source. And that's the era where we say from 1970s to early 1990s, the 2 decades that designers worked on the evolution of the buildings so that they would consume less energy. They would become less resource energy intensive. So no other resource was optimized because it was not pinching them yet, but energy was trying to be optimized. And you have some fantastic examples. I have some great case studies to show you from that generation what is happening. And then finally we see a fifth generation, and fifth generation continues that onwards since last 2 decades, again from early 2000s to whatever is there now, as you see some radical designs coming up. What we started seeing is the move of the skyscraper all the way from an energy guzzler to an optimized energy consumption to an energy generator. So this is where you started seeing, technology playing a very important role and enabling designers to actually have those goals. Having said that, I thought I should just put some kind of conditions to you in your mind, that when you design a tall building, what tall are you dealing with? Okay, and this is not limited to this. Multiple things required, but still. So one is you're dealing with air temperatures. So as an example, let me tell you that an air temperature that is there, that you sense an air temperature at probable in the sun, in the temperature on the facade where the sun is there, the sun facing facade, okay, at the say 0 to 10 stories is very different than probably like the 40 to 50 stories. Okay, it's much higher and much sharper up there. It is hotter below also from 0 to 10 now because of urban heat island effects that we have, but the temperatures are radically different across. The light quality is radically different across, you know. The light quality that comes, you know, 0 to 10 meters above the ground, or 0 to 10 stories above the ground, which is 30 meters, versus, you know, probably like 120 meters or 150 meters is very different. So you have, and then pressure, you have to deal with pressure and understand pressure and stratification. And density decrease with altitude. Wind speeds increase with height. And this is a subject I love, but I'm not going to get into as far as tall buildings is concerned, because we have some excellent experts here who will be talking to you about wind speeds, structural form, structural design, and I'm sure Mr. Gautam also must have spoken about the understanding of wind complexities as you go taller. So, you know, your complexity of your factors of design suddenly started increasing. Increased structural material requirements to resist wind loads, potential for wind downdrafts, greater access to solar energy, 100%, but also UV radiations, creation of significant shadows to surroundings, potential creation of urban canyons. What are urban canyons? They are literally these narrow streets. You know, in the first initial photographs which I showed you, it was more like an urban canyon. So sometimes wind drafts, you know, they funnel through these, and the increase in speed, creating extremely turbulent conditions at street levels or higher levels also. Now, in cities like Chicago, etc., where, you know, temperatures are really very unpleasant in winters, to have turbulent wind conditions, you know, flowing your clothing, hair, umbrella, everything all over the place. Even in Mumbai, I think to a certain extent in monsoons, if we yet don't have urban canyons happening as much, but there's every possibility in the Lower Parel district it will happen in the near future. But that's what's going to happen during stormy conditions, you know, or during slightly difficult conditions. So you started having these urban canyons happening. Requirements of vertical transportation of people and goods, and you have no idea how important this is. In fact, I think the primary understanding of tall buildings starts with that. And I'm so happy that you know, before this you had this fantastic lecture by Mr. Matthews, and he anyways always delivers a fabulous content, you know, and understanding. So, you know, looking at all this, as you can see, you know, we have so many things. So it's not a simple building that we are looking at. It's not a simple habitat that we are designing, right? We are talking about much more complexities which we are yet to discover. So many we have discovered and we are trying to resolve, and many more we are yet to discover. And somewhere in this whole mix, you know, what we are calling in terms of a little bit of resource efficiency and resource optimization, we have somebody threw this word of sustainability. And again, it's not a very old phenomenon. It existed forever. It exists forever. It's just been there in our conversations as a deliberate word only in the last 2 decades or more. So, you know, the thing, it takes me back because my journey with sustainability begins, you know, during my master's in 2001, 2002. And ever since then, you know, I've been with it. And you know, it ever since then, of course, this presentation will also take you just like, you know, a little understanding of where your buildings, tall buildings, are coming from. Also to understand where sustainability or our understanding of sustainability is coming from, because many of you, you know, have a lot of notions, which is excellent, I think, you know, and I'm sure many of you are interested, which I really encourage, and I would really inspire you to go ahead with that. But maybe we know a little bit as to, you know, how to see these things, right? I always say that, you know, what am I going to tell you that is not there available on the World Wide Web? What new am I going to tell you, right? But I'm not going to tell you about the what's. You probably have seen it. Probably I can help you look at the why, those relevant ideas, concepts, those relevant strategies are there in the domain. and maybe a little bit of understanding of how you can do this. And then I leave it to you at your best judgment to understand what is applicable to your design. So there is no one set rule that this is sustainable and this is not sustainable, or the three concentric circles, the Venn diagram you always keep seeing. That's an extremely old diagram developed in 1950s, 1970s. Like it's as old as that, almost like 50 to 70 years old. And I would encourage you veer away from that, because they are very, very stagnant understanding of a question that everybody began to have in mind. So why I have covered and I'll unveil everything else is, what you look at the bottom left is, so what was called as conventional practice. And I feel very bad, it's termed like that, but I didn't want to disturb the author's, terminologies. So it is true that, we were designing buildings as far as possible to be compliant to our codes. And trust me, codes are good, codes are not bad. Codes are meant to help us to understand what are optimum, or what could be, I don't know whether they are optimum, but let's say what are the minimum living conditions, that you could provide for. And I think this is a discussion that we've had along, even when we were discussing the chapter for NBC 2010, when the chapter on sustainability came out. I don't know if you're aware, the National Building Code, the latest release, and I'm sure college must be having a copy of that as a chapter on sustainability. It's a very comprehensive chapter. Do go through it if you ever require any ready resource. It's quite comprehensive. It's a pretty learner's guide, 101 sustainability guide kind of thing to go to know what to do, how to do. Like any code, it tells you how to implement measures in sustainability with basic understanding. So when we were having these, discussions, we were also discussing that, our codes, our building codes that are there, are they telling us what is minimum, or are they telling us what is optimum, or are they telling us what should be? So what is the benchmark? Should our benchmark be minimum safety, or should our benchmark be best safety? Should our benchmark be minimum performance, or should our benchmark be best performance? And I must tell you that this is still a question in deliberation. All right, we have still not come up to a certain consensus, and we'll move further to tell you about that. I'll come back to that idea of benchmarking. So conventional practices where we use building codes to at least come up with minimum compliance. All right. And then, as you saw the green embargo or the oil crisis that happened, you saw this entire generation of buildings, who were struggling to survive because they were energy guzzlers, resource intensives. You started seeing a lot of design revolution happening in certain relative green improvements. So that's why we call them relative improvements. Why? Because they were improvements from the minimum. So the building was performing to be a minimum. Okay. And so in other words, if I may say so, it was performing to be a little less bad than what it was, if I may say so. So forgive me for saying so, but sometimes it can be interpreted in that manner also. So one such project which is there, but extremely, I think, again, a very looked upon project, and we all respect this project a lot. It was at their time, this was in 1997 that this building came up. So it started its design in around 1990, 92. The Commerzbank Frankfurt, one of the most earliest, what we call as, ecological or a slightly more sustainable skyscrapers or tall buildings. Not all ideas were there at that time. Some ideas that Sir Norman Foster wanted to integrate. And some of them that he wanted to integrate is he realized that when we are going tall and when we are using glass as our primary material, glass and structural systems as our curtain glazing as our primary material, we are essentially living in sealed boxes. You understand what is sealed? Dabba, glass box. You're trapped there, correct? So if you have to survive in that, you have to keep pumping in air. You have to keep pumping out air. Now, air which is abundantly available if you open your window. The question is that can you open your window at a 40-story? No, you cannot. So understanding that logic, right, they devised a way of coming up with what is called as double skins. And I'm sure many of you are aware of this already. He embedded what is called as a mixed mode of ventilation using double skin. So this was a very, very debatable, highly debated also, highly applauded also highly criticized also concept of mixed mode ventilation. And I remember this very clearly because this was a part during my master's thesis, and we used to have substantial debates on this, whether mixed mode was, the way to go or not. But that was the mindset at that time. And we thought that, mixing natural ventilation with artificial ventilation would lead to a lot of losses, and hence it's not sustainable, or hence it doesn't necessarily do that. But, it's figured out nicely in this project, and you'll see a couple of diagrams after that. It also introduced what we call as sky courts. So thankfully, at that time, still, building was not parceled out. It was not compartmentalized, into okay, I designed the floor plate, you design the building system, somebody else designs the uh, probably, the engineering, the fourth person designs, all in a linear way. No, it was always integrated approach, which means that they worked with a much higher integrated design brief and design intention, that we want to design a tall building that could have. Why do you need sky courts? Because people out there realize that, if every time you want to step out of your office, you don't have a breakout space, you have nowhere to go, right? So every time you want to break out of your office and take a break, you would have to come down like 50 stories. Does that make sense? No, it doesn't make sense, right? Doesn't make sense any which ways. Even from going up and down like 5 times in the day doesn't make sense. Obviously you need, this is a place where, at least people were considered in design, I would always say. So there was a social connect, there was a community connect that was maintained. And one of the first buildings where you saw something called as sky courts that started appearing in tall building typologies. Of course, a lot of other mechanical systems, and I'm not going to get into mechanical systems because I think, you would need a little bit more probably, services to be done for that, and these are a little complex, so it's okay if you just understand. One is chilled ceilings. What chilled ceilings does is that you run some sort of piping and tubing through you embed them in concrete, and you run water, cold water or cool water. Let's not call it cold, it's usually water at room temperatures. That's good enough actually to cool your slab, a concrete slab. And concrete slab is a thermal mass, in other words, that it will retain the temperature. So if you cool your ceilings, your ceiling will also radiate that cool air down, and cool air sinks. So the room, gets naturally cooled and does not all the time require a lot of air conditioning draft to cool it. And then obviously the kind of chillers that were used were water cooled systems. What you see on the top right corner is what is a very, very, I think, radical concept of a central atrium that worked as a forceful chimney. So as you see on the right hand side, what's happening on that building? So it works as a chimney, and the taller the chimney gets, what do you get? A buoyancy effect, right? A chimney effect, as you call it. So it pulls air up, hot air rises, air on the top is warmer always. And then what they did is they started creating, what you see is on the sides, they started creating these small opportunities to ingress or take in cooler air. So as a simple concept, it was one of the first times they introduced that you can actually naturally exhaust your skyscraper, and you can naturally bring in cooler air in favorable conditions. Now, of course, I'm not going to do it, since this is in Frankfurt, I'm not going to do it in the heart of winter, but I can definitely do it all the way from spring to autumn, okay, when temperatures are a little bit more desirable. And then there was a lot of mechanics that was actually resolved, aerodynamics, which was resolved. For those who are interested, you should go and see this. Till date, I think it's a far more beautifully resolved tower, and has gone through multiple retrofits, but has also been resolved very beautifully aerodynamically. So what you see is some early sketches out there, and just some, I thought I should bring you some idea about, when I'm talking about the star was about 260 meters and the height of the occupied floor. So whenever you look at tall buildings and you read the case study, it's very important for you to understand that what was the last occupied floor. So usually the buildings, just because they want to score above, especially commercial buildings and office buildings, they go at least another 50 feet more, or at least another like 8 stories or 10 stories more to kind of get to the height. And of course, they have lightning arresters, and I'm sure Anuja and the design teams will talk about that. Architectural design teams will talk about that. So floors above the ground were 56, floors below the ground were 25 elevators. Obviously, you can see vertical transportation was not as resolved, but still, and then the floor plate area that was there. So this is again just showing you how the air came in and how it exhausted out in the double skin that is there. Of course, the right hand top is the GSW headquarters, which we will see at a later stage. Also, a lot of passive design strategies were used. So the orientation of the building, then the kind of glass that was used, the double skin was used so that, whatever air is trapped between the double skin gets exhausted up, and thereby, you create a natural current of air. And then you just need to open or create very, very small, delicate, little openings to your curtain glazing. I hope you do understand that just like we open an openable window in a 4-story house, we cannot go to the 20th and 30th story and open that. And I'll talk about that, is that, how and why are we dealing with sliding windows on 20 and 30 stories also in residential buildings today. I don't think that's perfectly the way to go, but nevertheless, that's still something that I think we're all figuring out. So something that I also would like to tell you that, there are no absolute answers to this typology. This is a typology that is barely 150 years old, 120 years old, and we are all resolving it along the way. There is no one answer to it. So somebody may have resolved something, somebody may have resolved something else. And I was telling Anuja and Parikshit that, I'm here to help you, of course, understand, but help you also raise a lot of questions, because there's a lot of things that are done. We've been too absorbed in doing things, in creating technology, but not wondering why we need that technology. The whys have not been questioned very well, and I'm a big fan of whys. I really love to understand why we are doing it before we put in, the next 2 decades of our lives into resolving something that we felt created a problem. Because you saw in the evolution, right? You resolved one, you brought in the curtain glazing, it created new problems. So, if you don't think through, it's always going to create new problems, right? So I think a little bit more thinking is required. What you see on the bottom right-hand corner is the graph where, you can see that how well for that period the Commerce Bank performed up to 2008, and it's been substantially, its operating cost as far as energy was concerned has been low because of the passive design measures that have been taken into account for this building design. Another such building, of that 5th generation that I'm talking about is the very famous Swiss Re, London. For many it is called as the Gherkin, 30 Saint Mariacs, and it has a few more names, slangs, which I don't want to get to tell you about, the Cucumber building, and so on and so forth. This also had, a double facade. It had a very complex external skin. It had an exoskeleton, which also helped balance the internal core. So structurally, the way this building came up was very interesting. It facilitated travel of hot air upwards. So again, it was wanting to use the same principle of the double skin where, the hot air travels upwards. And, they had a lot of sensors that would control all these kind of environmental systems, as in when would an opening open so that, cool air comes in, hot air goes up. There are flaps, there are motors, there are sensors. So things started getting a little complex. Okay, now you probably are detecting a pattern because, we are automating things and we are bringing in sensors in play, but they are done with to control only the first problem that we are not thinking the problem through. And that is why, if you see, it did well. I'm not saying it didn't do well. It was speculated, and this is yet not proven. As you can see, that's the draft movement that was speculated, expected to happen. That it may reduce the energy consumption by 50% on an average day across the year. But, this mixed mode criteria was not working very well. What you see on the right-hand bottom is, a diagram which shows that if a mixed mode was working well, you would have seen a lot of arrows across the entire floor plate. You can see a lot of dark blue spots. That means those are stagnant areas. That means that air is not pulled out of the building and it stays there till the mechanical system doesn't pull it out. And trust me, a lot of times if I put the mechanical system in this simulation, there's a CFD simulation called as computational fluid dynamics simulation. And this simulates for me what are my dead spots, because it's working. It's a little technical the way it's working. The mixed mode criteria in this building is kind of found out that it's not entirely working as designed for or speculated. I think it's fine. It was still there was a attempt made, but too expensive an attempt, and floor plates were not optimized due to abstraction. So if you look at this, this were the initial sketches, and these were the form explorations of the building. On the right hand, you can see right hand side, you can see what the floor plates look like. They were varying floor plates, and there was a lot of abstraction to the shape of the floor plate, because of which offices were not able to get the maximum real estate value, and this is where the building was a little falling out in terms of its commercial proposition. Now I can assure you that that is also one of the primary things that you should keep in mind, because the efficiency of the floor plate, and this is again something I'm sure that architectural design will deal with, and I hate calling it a separate section, but I'm here to talk more about a particular aspect. So let's say integrated design would deal with, and we call it as floor plate efficiency. And your floor plate efficiencies have to be designed for, because a tall building typology is a very expensive typology to design. It's capital intensive. Now, if you are not able to optimize it from a capital standpoint, it's a real estate as well as its construction cost standpoint, and it lies underutilized, I think then that's a grave mistake that is made, because you are anyways creating such a liability on the environment, and on top of that you have underutilized it. I think some real rethinking needs to be done as to what was the beginning of the design process at that time. So what should be done, right? Some very quick understanding on, and this is not entire sustainability, but this is just one aspect of sustainability, that is energy I'm talking about. So one of the primary things that you can look at is orientation and massing, and you have some tools and softwares available today. I'm sure your EVS will deal with it at some point, and you're going to look at how the building is going to gain heat, or how the building is going to lose heat. What are the wind movements around the building? What is the humidity in that place? What are the pollutants? Something that we've not been dealing with in the early 2000s, and we are dealing with substantially today, is pollutants. So, the urban air quality that we deal with. What are the pollutants that we are dealing with in a microclimate, or surrounding our skyscraper or our site? And we are looking at the entire climate at a macro level, which is, we call it as a latitudinal level or city level, and at a microclimate, which is your neighborhood level. Both are extremely important for you to design for and understand. What you see on the left hand side is what we call as, the comparison of surface to area volume. Now, why is facade so important? Because in a low-rise building, based on your floor plate area, your surface area of your facade is very less. Compared to that, your tall building, your floor plate is hardly like 40%, and 60% is your surface, your surface to volume ratio, as we call it, which means that your facade areas are huge compared to your floor plates that are there. And because of that, your facades become very, very vulnerable to any kind of access of sun, wind, light, and all the environmental or climatic parameters that we're talking about: rain, snow, storms, earthquakes, etc. So, one of the other strategies that we always say is that once you determine an optimum orientation, which means that do not face your building where the heat radiation is maximum, right? Face away from that. Now, if you want to face the building in that direction, or rather face the habitable space in that direction, then you'll need to take more measures. So, the first and the best thing is, that what is our natural response to harsh sunlight? We look away, right? So if you can look away, preferably do that. And that's why it's very much decided, the orientation and massing is decided in the initial stages of design. You could take these decisions early on to avoid substantial costs in your facades and material choices at a later stage. Now, ऐसा हो गया है कि I'm facing the sun. I decided to face the sun. So now what do I need? I need a cap and a set of glares, right? So I have my cap or my shade, and of course we have beautiful shading devices that could be put on your facades or could be designed for. But I'll caution you a little bit that these have to be understood even from a wind point of view or aerodynamics point of view, and how the building would perform from an aerodynamic standpoint. So it's not as easy putting a solar shade, as we call it, or a screen on your windows or on your facade is not as easy as shading a 10-story building versus a 60-story building. There's a huge complication there. The wind behaviors are very, very erratic. So you have to understand that, and that goes through a lot of study. It goes through a lot of analysis to understand what sort of shading devices could be done if they have to be done. So once I've figured a right orientation, once I have said that, okay, after orienting, I still need to shade a little bit, I've brought in some shading, then comes obviously your material choices, the kind of material that you're using. It should have certain amount of what we call as insulating properties, if I may say so. So some amount of insulating properties, some amount of resistance to either cold temperatures or hot temperatures, depending on the climate type you're designing for. Then the next thing that we are looking at is that another thing that consumes a lot of energy. So why did we talk about heat gain and heat loss is because one of the most primary consumptions or consumers of energy in a tall building is your mechanical systems or mechanical ventilation. One of the easier ways of optimizing the load on your mechanical systems is using passive measures. And what we spoke about were a couple of passive measures. There are many more that can be done, like what you saw: single facade, double facade, triple facade buildings. But you can keep exploring. I'm just giving you the logic behind as to how to look at these things. The second thing that people have is what we call as daylight optimization. So what happened is that if you do not optimize your daylight, you will start seeing a huge consumption by way of artificial lighting. And artificial lights also consume a lot of energy if they are kept on for like 12 hours, 14 hours, 16 hours, etc. Now, of course, with the intervention of LEDs, you have a different story, but then why waste, right? It's very important. So daylight optimization becomes very important. Now, why am I saying optimization? Is because one of the hardest things I have realized in designing for tall buildings is right light. RIGHT, right light. Okay. The higher you go, the greater your glare component becomes. And these are again several studies that you do through various softwares to try and understand how can you optimize the daylight. You can use certain strategies which are called as shells, light shells, internal light shells, external light shells, and these are very small projections. These are kind of light shelves. They're not weather shades. So they can be as small as sometimes like 230 or lesser than that, 150 also sometimes, 150 mm, 230 mm. So what you have to understand is that when you are designing your floor plate, and this is again taking you all the way back to the initial part of your design, is that make sure that they are not very deep. They are not very, very deep. So if it's a very tall, as you can see the top right hand image, more than 50% of the floor plate is blue. That means direct light doesn't reach. It's too deep a floor plate. The width to depth ratio is very, very deep floor plate. So as far as possible, design floor plates which are not very deep, which are not very far, such that they are very far from the window. The far end of the room should not be very far from the window beyond a certain point. So as if you could cap that somewhere, if you could figure the geometry of your floor plate, the width, the depth of your floor plate, the length of your floor plate, it would substantially help you optimize daylight. Now, earlier daylight was always just optimized from a point of view of, we always looked at it, nahi kiya to energy consume hoga. But what we have realized in the last few years, almost close to a decade, but I would still say 5-7 years, is daylight is a very, very important concern as far as well-being is concerned and health is concerned. And if I have very dark spaces in my tall buildings, I can be assured that my people will not be mentally or emotionally or psychologically very healthy. And then there are physical health issues also, which, health and well-being we can talk about in a discussion when we want to. Also, when you go very high, very tall, there is UV light which you need to take care of. So when I'm going above 100 meters, from the ground, the quality of light, the radiations are very different, and we need to be a little aware of that idea. We need to make sure our material choices are accordingly. And solar shades for controlled daylight levels. Again, the light shelves that I was talking about. So some of these are kind of, fifth generation kind of approaches to passive solar design, as we call it, or climate responses to tall buildings as they were done. And one of the interesting projects is what we call as Blight Street. You can look that up. Blight Street is a tower in Sydney, and it has a good amalgamation of a lot of these strategies. It has a 120-meter tall atrium with exhausts, a lot of hot air that is accumulated. It brings in cooler air. Now, mind you, Sydney is not a climate that's like a London or like a New York. It's a temperate climate. It's not very hot. It doesn't get very cold. So, if you do something wrong here, it can go drastically wrong. Like, you can tremendously heat up a building if you don't take care. So, this was, a building that used, as you can see at the bottom, it allows natural light to penetrate to some of the deepest spaces in the floor. So the depth of the floor plate was controlled such that there was enough light penetration. The stack effect drove the natural ventilation, and it was well controlled and understood. There was thermal comfort in the ground floor, which were public spaces. What is thermal comfort? Thermal comfort is that, where human beings are comfortable between a certain range of temperature and humidity. And it's essential that in man-made environments, we try to maintain that. So ventilation is one of the ways of making sure that you are well comfortable. Offices are mechanically ventilated for commercial reasons, but a double skin facade allowed perimeter spaces to be naturally ventilated if desired by the tenants. A lot of perimeter spaces, which you see on the right-hand side around here, these were all tenant spaces, or more like outdoor spaces, semi-outdoor spaces that people could use, that were not necessarily, indoor spaces like office spaces, and they could be controlled by natural ventilation. So a fairly resolved space, fairly resolved. I visited this place, and it's quite nice. It's functioning quite well. The Blight Tower is something that is of very recent completion. The GSW headquarters in Berlin. This was again a late 1900s, early 2000 kind of typology, and this was also optimizing ventilation and optimizing reduction in energy gain, heat gains, reduction in heat losses. You started seeing insulated glasses coming in, single layer, double layer, triple layer insulations. So you started seeing a lot of revolution in understanding of, the market started releasing many, many, many more materials which, could combat the extreme conditions that you constantly have to deal with when you keep going taller and taller. Now, on the other side, parallel, what was happening is, while these, fifth generation buildings were evolving, you saw this again huge evolution from like a little, I would say approximately 2000s, a lot of bodies. And I could have extended this list and filled the whole page, but there was a Green Building Council, a USGBC, IGBC, GBCI, Falana, Dikna, everybody, and this whole term of green building. So I'll be honest with you, when we started studying this whole idea of sustainability in our masters, and this is almost 2 decades ago in 2001. And when we were studying about climate, and we were studying about tall, any kind of building, climate responsiveness, the term green building was never there. Okay, so when the term green building came in, it was very awkward. Like, so what's a green building? Why not blue building? Why not pink building? I mean, green because of nature, symbolic. Yeah, sure, why not? But fine, if it's a common man's word, let's go with it, and let's look at the green building typology. So you had these green building rating systems, as you call this, and green building councils that cropped up all around the world. Okay, not less than 600 such bodies came up in the last 15 years. Many of them, as you can see, are names that are there. And what they started doing is they started benchmarking performance, obviously, because when the 5th generation buildings started coming around, we were speculating what our building would perform as. Okay, we were not knowing what it was performing. We were only assuming, we were estimating. So one is estimating and the other is measuring the performance. So these rating system says, now let's be sure of what our building is performing for. Of course, most of the buildings, by the time they resolved and they started measuring the buildings that they built using these rating systems, was again another decade later. So they broke it down, they broke down into site, water, energy, materials, air quality, well-being, and other criteria, many criteria, and different rating systems. Somebody dealt more with well-being, Edge dealt with excellence in design, BM was with Hong Kong, Green Star was with the Australian Green Building Council, CASB was Japan, Living Building Challenge was Canada and US, BREEAM was UK. BREEAM was actually, you can say, the mother or father of all rating systems. That was the first rating system in the world that, where it was actually developed at a university, at a lab, building performance lab at a university, that spoke about that let's develop a performance criteria benchmarking system to understand what our buildings are functioning for. So they had several of these criteria, and so side by side, while we were doing this, trying to understand, what is our environmental footprint, or how are we are resource intensive. And mind you, when I'm saying resource intensive, I have yet only spoken about the energy part. I have not spoken about water or waste or other aspects yet. And they have not been worked on as much as energy has been worked on, but we'll continue. So these started coming in, these started giving us a sort of a guideline as to what should be done or what should not be done and how it should be done. What should be your benchmark? So, these buildings started becoming more like benchmarking devices. Now, this is where I want to take your attention back to. Remember, I was talking to you about the benchmark. So what should be a benchmark? So should a benchmark be like the bare minimum, or should the benchmark be the best? And sadly, I think we are somewhere oscillating in between that as a global civilization. So we are benchmarking ourselves against something that is anyways bad, that has anyways a carbon footprint. We are saying isse thoda kam karo. So we have accepted that if we design a building, it's going to be bad. If we design a habitat, if we create anything, it will have an environmental footprint. We have accepted it. And then we are saying, abhi isse thoda kam kharab karo. So the logic behind these, many of these, not all of them, many of these, started getting skewed a bit. That, when you talk about performance optimization, we proudly say we optimized more than dash. But what is that than, right? Is that than justified also? Correct? It's like I can give you an example that I remember listening to this Cradle to Cradle lecture, and the author of Cradle to Cradle was William McDonough. He was showing us this plastic duck, and this plastic duck, if you look at the back of the plastic duck, it had like it is toxic and it is this and it is that, and do not put into your eyes. Your mouth, and do not do this. And the toy is meant for 0 to 3 years old. Does that make sense? How can you create a toy for 0 to 3 years when you know that the kid from 0 to 3 years is going to put it in their mouth, and you still create a toxic toy? So what do you expect the kid to do? To just look at the toy? That means your benchmarking is what? I don't even see a benchmarking in that example, but still, the benchmarking is bare minimum there. That the kid should not be poisoned. That's about it. I mean, that's that bad, right? So we are not looking at that kind of benchmarking ideas. We should look at far better benchmarking ideas. So these are all parallel journeys, huh? So don't get confused. I'm just showing you a lot of parallel movements that's happened along the tall building scenario or tall building criteria. And at the same time, in the last 2 decades, as many of you are aware, we saw the skyline in India and Asia change. And these emerging skylines were largely commercial, residential, or partly mixed use buildings. Okay. Which means that we need to start thinking that all the case studies that we are looking at are outside our Southeast Asia. What about Southeast Asia? Because the problems or the challenges of Southeast Asia are completely different than what we were looking at in the past. So, we started looking at some more examples, something closer to home. And I'm not saying this, and I'm very proud to see that, I still see 1 out of 5 journals or 1 out of 5 books that talk about tropical skyscrapers in Southeast Asia always refer to Kanchenjunga. Of course, there are things that didn't work probably there, but that's for every building, right? Some things work, some things don't work. Some things go as planned, some things don't go as planned. But there was some amount of inherent deliberate intention that was made towards embedding natural ventilation, which was the source of primary comfort for a climate like Bombay, and that was somewhat achieved, I feel. What you see on the left is, a beautiful building. It's called as the Met. It's in Taiwan, and this is a residential building that is there. And as you can see, I've just brought. I don't know if you can read into the apartment floor plans. The apartment floor plans are such that it's not a regular shape, as in it's not a clean shape. There are a lot of ins and outs. Okay, of course, it's difficult again from a structural and a aerodynamic point of view. But this helped for the building to get a lot of shading, to get a lot of pockets of ventilation, get a lot of pockets of air, especially in climates like Bombay, Taiwan, etc. Because if I have a smooth facade and I try to open my window on the 20th floor, what's happening? It's going to bang shut. So I need to open it in a pocket, in a recess, where the wind intensity is not there, and then I can comfortably open. So I get the pleasure of opening a larger opening, but I need to deliberately create these recesses by the shape of my floor plan, such that it becomes more and more easy for us. Okay. Again, wind is a whole different subject for ventilation in tall buildings, and I'm not sure I can touch upon all that today. This is again another building that I'm talking about is National Library in Singapore. So these are all in Southeast Asia, and you can see these are the last 20 years of design ideas that were evolved. Of course, it dealt with the facade, it dealt with light shelves. What you can see on the left hand side is a light shelf and a facade development. What you can see on the right hand side is spaces that were created for comfort and social connect, that were shaded. So these were public spaces that were created. Also, what you saw from those spaces. So one thing which, if you remember all the way on some of the initial slides I showed you, is something that people were aversive about tall buildings is the isolation, that once you go up, all you can see is inside or completely outside. There is no relationship to people, there's no relationship to each other, there's no relationship to community. So these are the buildings that started actually developing these kind of relationships. Another building which I want you to look at, as a part of your case studies, is National Commercial Bank, and this is in Jeddah. Again, a very nice case study. What you see in the right-hand side is, one of the older cities in Yemen that, still had a taller residential building made out of mud, not brick, mud and mortar, and it's extremely difficult to go tall in that, but they did figure. Of course, they had a lot of problems with it, but still, it was a city that was created in this fashion a few centuries ago, and they actually kind of took in a lot of learnings from that. So what were the learnings they took in is create shade, lots and lots and lots of shade, because you're in a climate which is hot 80% time of the year. I think it is a crime to not protect from the sun in a climate that is so exposed from a solar standpoint. So what you can see is the view from the office floor. So even when you see from the office floor, you have a sense of visual comfort, you have a sense of connection to the outdoor, to the urban environment. And you don't have to squint your eyes, it's too bright. See, many a times when you stand near the window of a tall building or any building that's in the sun, you can't see outside because the sun is right in your eyes, right? So it's very important to create visual comfort. On the right hand side, what you see is, again, the topmost floor has a perimeter glazing that you can see, but it is shaded by a stone columnate that is created. So there's a lot of shading that is created. It has a good amalgamation of contemporary design elements along with traditional understanding and wisdom. So, a lot of shading was created inside, to shade the harsh sun and to reduce the load on the cooling systems. Again, one more building that you should look at is the Wind Tower at the Salmiya, Kuwait, and this is a beautiful building. I think it's a residential building that has been created, and this has a lovely wind tower effect. The Malkafs, the wind towers that are very famous in the Middle East for removing hot air from spaces. It was quite a successful intervention that was done in the tall building typology in the recent past. And, see the diametrically opposite intentions we are seeing. The previous case studies were all struggling to stay warm because they were all from cold climates. These case studies which I'm talking to you are all hell-bent on staying cool. Okay, they are hell-bent on being cooled all the time. And that's where your strategies will substantially change. They'll differ. Your focus, your intention changes substantially. So and also what was very nice is the arrangement in the cross section that you see on the right hand corner is, the ability for people to connect with each other as a community. So this is where people could actually start relating to them, to each other. It was not like as if you had to come out into the lift lobby and that was the only place where you could have a connect in a tall building typology. This is the floor plates that I thought you could probably just take a look at. As you can see, it's a beautiful stagger that is happening. That when you cut the cross section, even the central atrium is staggered. The atrium is staggered to give you slightly that sort of effect, and it's staggered with multiple kind of terraces, courts, overlooking areas, etc., etc. So, having said that, where have we reached as far as sustainability is concerned? So, from green relative improvements in terms of what I spoke to you about the rating systems and what you saw as the fifth generation of buildings in Europe, like the Commerzbank and the GSW headquarters, etc., which were a little better than a benchmark as understood by the green building rating systems. We had these new concepts that came in the last 15-20 years again that said that okay, we don't only want to be better than the bad, we want to now come to a neutral point of saying that we are not doing any more damage. Now this is where you've heard the famous net zero, okay, but this is net zero energy building or net zero carbon building. Now again, I might just want to bring your attention to the very fact that when I say net zero energy building, we are only dealing with energy as a resource criteria, or a net zero building. If I say, and I don't say NZEB, I just say net zero building, NZB, then I'm probably dealing with water also as a criteria, but definitely not materials. Also, let me tell you, most of the time, the definition of net zero is only dealt from the point of view of what we call as operational. That means I'm not taking into consideration what is called as the embodied energy or embodied impact of creating the building. The energy, the water, etc., the resource footprint that happens, the ecological footprint that happens when you want to create a building is not taken into account, or maybe cannot be taken into account by this logic. I'm not saying it should not be taken into account, but by this logic. So what I'm trying to say here is that for the amount of energy that I consume, all right, I want to generate equivalent amount. So it's okay to a certain extent, but it is assuming that you're doing a total global math and you're saying that I'm equivalent to this, or you are polluting on one end and regenerating on the other. But it still has a little bit of a how do you say, a discord to it, and we'll talk about that when we discuss. But keep it in mind, so net zero energy buildings and net zero carbon buildings. As we saw in the fifth generation, this is that journey where the buildings saw this huge uplift of renewable energy, or this desire to generate their own power or energy and be self-sufficient. Now, how I wish this desire was as strong in the water sector. Um, we've been wanting to be water positive. We are okay in water efficiency, I think. But definitely, I think in a tall building scenario, being water positive is an extreme challenge. Again, from a space, etc. point of view. And maybe we leave that discussion for another day. But we'll come back to it. If any one of you has that question, I'd love to discuss that with you. So from reducing energy consumption, we started generating energy consumption. So, to be net zero energy, you cannot be net zero energy if you have a leaking bottom. In other words, that you keep consuming lots of energy, then you have to generate that much more. It's not easy for a tall building to generate energy because their surface area to generate energy is limited. It's either the rooftop or partly the facade. But as you know that the facade is not always oriented in the direction of the sun. So on an average, you get not more than 30-35% of the year on the facade. And the maximum energy generated is still by way of what we call as rooftop solar photovoltaics or rooftop PV. Okay. The other thing that was crucial or important was wind. So one thing which low rises couldn't capitalize on, and maybe certain tall buildings could capitalize on, was wind as an energy or a source of energy. Of course, wind has its own challenges. There's a lot of vibrations, the load, the motor, the conversion, the efficiency. But still, I think the resolve is very strong that either using wind or solar or both, we want to generate our own power. So what net zero energy buildings or net zero carbon buildings were trying to do is that whatever was their operational energy consumption, right? So they would reduce it substantially by using passive measures first. And once it's reached to a bottom low, then they would generate that much such that they are able to be off the grid if possible. So that was the aim. Let me tell you, very, very few buildings have proclaimed to achieve that. It is yet to be proven in many, but have not achieved that entirely. What you see on the right hand side, I've just got you a small table, and you can look at the bottom two buildings. Is that the RWH2 and the 2 Win Plus Energy building. It's a small residential building. It's not a very tall building, let me tell you that. And only in that building, okay, it's both were in Vienna. They were office buildings, and they had on-site energy generation technology in place, by way of which one was able to generate 61% of its solar energy, operational energy, and the other was able to generate 109% of its total energy requirement, or in other words, be energy positive. And these are very, very valid sources that are actually giving them. All the other towers that you see above are trying and struggling, but they do manage to generate only 10-30% of their total energy demand. So people started becoming very smart, and they started saying, okay, not net zero, let's make it near zero. And again, near zero became a very popular term where people wanted to take their operating cost, common area operating cost on renewables. And that started becoming more possible. But, again, like I said, we are still far away from net zero, complete net zero tall building. Net zero communities, small low rises have managed it, have substantially reduced their footprint, but net zero tall buildings is something that's still a challenge. And in fact, the entire community of tall buildings many a time speculate that can a tall building really be sustainable or can really be net zero. So moving from there, we spoke about the environment a little bit. We spoke about buildings and buildings and buildings, and we spoke about buildings and facades and systems and sun and everything else. But what we've not spoken about is people. So something that I feel that you should never leave. It should never leave your mind is that everybody else will facilitate servicing the building, but you as the architect has to design the building for the people. The people should not be forgotten. So it's very important that once you have an understanding of your technical systems, don't be so busy in resolving your building that you forget to resolve for your people. So from technical systems, how do you come back to living systems? From inanimate to the animate, and from man-made to the creations of nature. Very, very important that you have to come back and understand what is man's social need, what is man's visceral need, primal need, inherent need. How does he behave? You cannot put him in a device in a building that operates like a machine and expect them to be happy just because it's a highly optimized net zero building? Well, it may not be a happy building, but it may be an extremely well designed facade, but people may not be happy in it. Why? Because your primary goal is to actually facilitate spaces that can deliver social requirements, social conditions, keep it conducive to social requirements, well-being, designed for the health and well-being. And health is not only physical but emotional and psychological also. So coming back, now we are unveiling, this is what I wanted to show you, and I'll come back to the previous slide. So as you saw, bottom left hand corner, conventional. Okay, we spoke about that. Green is the rating systems, that is just relative improvements, that is saying I'm less bad. Sustainable neutral point is what we spoke about, net zero, but for tall buildings that's a little hard. But the whole world of the domain of sustainability, and like I told you, the community of sustainability, people who are actually passionate about these goals, move forward in a far, I think, productive way. I'm not sure if tall buildings have yet followed it, but what they said is that human beings need to figure their their journey from conventional practice to regenerative. In other words, is that let's not just be carbon neutral. Okay, that means we are having a footprint and we are negating the footprint. So what we are saying is that let's be restorative. In other words, can we restore what we are damaging? So not just going net zero, but going net positive. Reconciliatory is nothing else but reintegrating human beings as an integral part of nature. Very, very important. How can we be away from nature? So it's very important to bring back the primary fundamental elements that are required for the inherent emotional, psychological, human consciousness. Human consciousness is guided by these subtle aspects of the environment and nature around. And let's bring that back. So how do you integrate humans back into nature? And finally is appropriate participation and design in nature. Now, can you give back to nature without, so forget harming, can you create more nature? Can you become a creator? So that's how nature functions, right? Nature doesn't function as a destroyer first and creator later. So that's what we are doing right now. We are destroying first and we are feeling good that, oh no, now we are recreating, or we are less destroying, right? No, can we go all the way and say that we are going to be positive creators? We are going to be positive creators and contribute to the creations in nature. We can. There are examples of that. And we might go through it. So this is the diagram that talks about, how do you integrate sustainability into the human consciousness? Because sustainability is not a concept. Sustainability is a way of life. It's a value system. It's a belief system, right? And whether you, as living beings, we live in buildings, shelters, we participate in ecological subsystems. We have our site, neighborhood, community, watersheds, biome, and finally the larger, the larger region. Okay. So what you are seeing on the graph is that, what I have highlighted as the blue circle, what you saw today as a part of sustainable development and kind of case studies in net zero or near zero is only this part where, from degenerative design, we have just moved to conserving resources, or at the most we've moved to a living building challenge, or affiliating ourselves with nature by using biophilia, ecological design, etc. But we are not going to become nature. We have not decided to go restorative, regenerative, or regenerative development or bio becoming. And that's the next high goal of all design, in sustainability, or all design, I would say. Why sustainability? And I'm talking about design as a whole, the world as a design, from product to fashion to everything that we can think of, from being a degenerative design to a regenerative development. Can we be regenerative communities? Can we be a regenerative society? So these are questions that we want to ask ourselves. There is a beautiful movie. I have not been able to get my hands on it, but if y'all can, it's called as Anthropocene, and it's by Edward Burtynsky. Edward Burtynsky is a Canadian photographer, and he has some amazing, his life work is using photography to convey the impact of mankind on the landscape. and you just have to see it to believe it. And he calls this age as the Anthropocene or anthropocentric. This is the age in the evolution of the earth where a substantial impact is made by man and man-made environments. So can we move from that and create biocentric environments that are integral with nature? So from being indiscriminate, not recognizing nature, and irresponsibly designing, can we go all the way and become nature? And I'll show you something about that. So one of the concepts that people use is C2C, that is called as cradle to cradle, and something that you must have heard, that is cradle to grave, that is life cycle of not only building products but also buildings, right? So what is the next upcoming challenge that we have? Resource. Water, yes. Energy, yes. But materials, right? What 100 years down the line, there is already a list of materials that is not going to be available for us to extract and thereby use, thereby implement, thereby construct with. And what are we doing with whatever materials we have? They are either getting built and put away in a building, or they're going to landfills. So we don't have a recovery of material. So we are actually putting away a very important capital into the waste stream. Okay, the very idea of having a waste stream, I think it's a very is being questioned today. And that's what we are looking at. These are called as linear design processes, or a cradle to grave design process, where you have resource extraction, manufacturing, construction, occupation, demolition, and you dispose of in a linear fashion somewhere else, right? But what is a cradle to cradle is where you bring it back into the cycle. So can we design an entire system, an entire economy to come back, into? So can our buildings become material banks for the future, such that today if I demolish a building, can it serve as a material resource bank for another building? It can happen. It's happening already in the product sector. So why can't buildings actually be coordinated? Why can't industries and the various sectors of the building industry be enough coordinated to make sure that buildings become a repository of their own material banks? And imagine the repository, the number of buildings that are there in the world. If each one of them became a material bank, right? We are banking our materials for 50 years in the building. If that is the case, imagine how wonderful that journey would be. And we would start going to, we would have not only resolved the issues with energy and water, but even material as a uh, resource consumption. So having said that, I want to show you a video that is there. Can you all hear it? Uh, Parikshit, can you hear the video?
No, no, no. Hello.
How do I share the sound?
There is one option. You share it with sound.
Okay, let me just reshare it. I'm not getting the share it with sound option. I'm just getting a share. Where is the share it with option?
Just a moment. When you share the screen, you
Yeah.
can see the so you can have that option, share with audio.
Okay, I'm
Your
gonna try.
it,
Can you?
Yeah, we can see the video, but
I don't know where to share it from. The option I'm not seeing. Okay, maybe I can just post the link for you all then.
yeah.
Yeah, and you can somebody can play it for me.
Acha, right now?
Parikshit, would you want to play this video? Can you play it on your end? Yeah.
Yeah, okay, I'll try. You will be sending it to me?
I'll just put it on. I'll just send the link to you.
Yeah. Or you just copy paste that link in the chat box.
Yes, that's what I'm doing right now. I've just pasted the link.
Just give me a second. It is uploading.
Let me know if it doesn't play. Then it's okay.
Yeah, just give me a second. It's not loading properly. Just a moment.
I think it's in the chat box, so students can take a look at it. I think it's all right. We can
Yeah.
just go further because we won't finish otherwise.
Okay.
I'll just
No
last
worries.
couple of slides are left. I'll just go there.
Okay.
So what I would say is that be it any design, be it any idea that you're looking at, um, what I call them as, if you want to go all the way from conventional to participatory in design, all right, I call them as fabulous R's. And these become great questions. These become great questions for to facilitate your why when you want a why to be answered. So one of the first things is reduce. What needs to be done is reduce, use only what is important, optimize such that you reduce. The second is reuse is where you use it without altering it much, but reuse and refurbish are two bits. Refurbish is where with minimal modifications you can reuse it. Refurbishing it a bit, strengthening it a bit, or bringing it back or altering its use. You can reuse and reuse your material, your system, whatever you want to look at. Third is recycle. Recycle is where you break down the components again. So you must have heard the idea of recycled economy. So we are still in a recycle economy, I feel, and we need to move much further. We need to move from a recycle economy to a regenerative economy, and a regenerative system. A set of things that actually allows us to do that. The fourth thing that I love is rot. I mean, in other words, age. In other words, allow things to die. It's okay. Things don't have to last forever. Everything doesn't need to last forever if you understand the life cycle of that thing. If you know that this thing tomorrow becomes something else, it goes back to nature. Sometimes it's good if it goes back faster, because then it's available as a resource to nature in a much faster manner. Okay. So sometimes it's okay for things to go away, and sometimes it's okay for things to degenerate. Uh, in fact, there's a whole school of thought that talks about design for aging, and I think it's a beautiful way of looking at things. Replant, bring new things out there. Respect, very important. Respect what is there. I think today a large set of problems we have is because we don't are not respectful about a lot of things that we have around us. Refuse, a very important strategy. Refuse what should not be done. uh, Refuse becomes your very, very strong tool to say that, okay, I will not use this kind of material, I will not use this kind of strategy, I will not use this kind of design approach which makes my people live in isolation. Refuse, refuse, refuse. Be very clear about what you don't want to do, then you will know what you want to do. Sometimes students are not clear. Why students, even professionals, all of us, we are not clear sometimes about what we want to make. I think it's very important that then you realize what you don't want to make. What are the things that you don't want, and that clears your path for what you want to make. Replenish, whatever it is. If you can replenish, you can go positive, add positive to a resource or to whatever that you are designing for. It would be a fantastic approach. Rethink, always rethink the way you're doing things. Relook at it, go back to it. Don't blindly and keep going on over and over and over again, because nothing new arises or arrives out of doing the same thing again and again in the same manner again and again. If you want to innovate, you will have to move away and do things differently to do something else. Okay. Repair whatever is uh, not doing well, right? Before throwing it away, if it can be repaired and used, if it can be retrofitted, as we call retrofitting, is a huge part of repair, and retrofit is a huge part of our industry again today, because we have a large crop of old buildings that are there. Reinvent, yes, definitely reinvent, relook at a lot of ancient wisdom, a lot of past wisdom, a lot of lost wisdom, and apply it to today's context. When we talk about reinventing the wisdom, we are talking about making it contextually applicable. And you saw that in some of the strategies in the building in Jeddah and Kuwait, etc. Recover whatever is lost. Okay. Responsible, be responsible towards what you're building, be accountable towards what your project does or what your design does. Finally, restore. So after doing all of this, I think going just positive and becoming a part of the natural system should be a piece of cake. um, and having said that, it's very, very important that as much as you learn to design the building and put together the building, and learn to bring components of the building together, it's very important to design for vertical communities and people, because you're designing these essentially for the people, essentially for the users. Some of such strategies, as you can see, mixed use programs, single use programs, but how beautifully some of them are actually created. The Shard Tower, the Price Tower, the Rotterdam Tower. Some other strategies which are used is, the School of Arts, where the Sky Terrace. This is in Singapore, where the Sky Terrace was used as a place for student interaction on the left hand side. A verticrop is, again, a vertical hydroponic growing system, a vertical farming growing system, an extremely, like I said, debatable concept today. A lot of argumentative, arguments happen on this front. A lot of beliefs and disbeliefs in this area. But I would say a lot of, resolved ideas and strategies that we see today, like mixed mode ventilation, double facades, triple facades, etc., all started at this mode of debate. So I think if you resolve the why and the intention of why you want to do this well, you will end up resolving all the glitches that come along with it. If your why is substantiated, then it's worth solving the problem. Um, some other things like, yeah, some strategies of how these hydroponics are done in tall buildings. So these are new concepts, fresh concepts of bringing man and nature together as man and nature moves away from the sky. This is a plan of the same aquaponic farms. So it was called as, agri and a culture of agriculture. So how can you bring a culture of agriculture in the next future communities? I would say that, doesn't matter whether you're designing a tall building, you're designing a low rise, you're designing a bungalow. I think it's very important to bring back the connection of man with nature in whichever way you can actually desire, design, understand. How do you consciously connect with nature? A large part of human consciousness and human culture gets lost, I think, if that visceral connection to nature is lost. What you see on the right is the Shanghai Tower. That's a communal lobby again, at the base of which almost forms like a neighborhood congregation for that tower. So future concepts, I would always say dream away. There's nothing like it cannot happen. It will happen, maybe not now. It'll happen 50 years from now. Like one such concept is, a clean air tower that you see on the left hand side. Can a tower be created that is able to absorb atmospheric pollution, clean air, and reverse air circulation? It's able to take in pollution and leave out fresh air. And this is somebody's idea. This is somebody's dream, that can our buildings that are polluting today depollute the environment. Another intention of agriculture, as you can see in Sydney, somebody was talking about ground level and higher levels of vegetable and fish markets at much taller levels, because we are looking at urban communities which are far away from the ground source today. Um, some more examples of what that agriculture, etc., looks like. So having said that, I would just love to end this right now to hopefully inspire you, hopefully trigger you, that let's rethink, stop, pause before you design. Ask why are you designing, and what is it that you intend to design. And the why and the what of your design is very, very important, because if you're spending your entire energy only on designing either for the building or the building system or the building facade, it's not worth it, because you've forgotten the people for whom this entire effort has been going on for the last 150 years, to put man up in the sky, to experience livability up in the sky. Good, bad, ugly, we don't know. But if you forget the primary purpose why we started going tall in the first place, I think we need to relook at why we are doing things. And once you know why you want to do that, right, then you definitely can go and figure out the how. Sooner or later, you will know how to do it. Having said that, there was one more video I wanted to show you. I'll paste it in the chat box, and you all can see it on your own. But that's the end of what I would like to speak to you as far as sustainability in tall buildings is concerned. And yeah, questions. Any questions?
Yeah, thank you, Meenal. Hello. Yeah, thanks, Meenal. Any questions from the student? Any questions from the student?
I think they're very tired. We had a long day.
No. I mean, it was such an interesting lecture and eye-opener questions. So it was nice interaction. Any questions from the student? I don't think.
Oh, sir, I have a question.
Yeah.
Oh, yes, ma'am. So I want to know if there are any skyscrapers or structures in Mumbai currently that are practicing things like aquaponics and harvesting energy and such things, and how is it being done?
Not that I am aware of yet. As far as I don't know if they are on the design boards, then we probably wouldn't know much of them. but they are not built yet. Where they have actually looked at these kind of strategies. So not yet, not in Mumbai.
Okay. But hopefully we are expecting something innovations from the.
Well, they are change makers, no? These people are change makers of tomorrow.
Yeah.
So we have a whole new set of innovations disruptions that's going to come from all of them.
Right. Vinit sir is also here. Vinit sir.
Can
Oh,
I
okay.
can I say something? Uh,
Yes, Anuja.
yeah, okay. Just to answer him, uh, I think it's the awareness of the developers. Um, it's very important in the case of Mumbai. There is no lack of intellect or drive to implement all these systems. That's what exactly Meenal's presentation talks about, that how the integrative approach and how you can convince your client that how these strategies are going to help them in the long run. And that's where Meenal's presentation is all about, where it's what she talked about, the life cycle assessment is to understand that how these benefits are for the long run. So the developers or the owners who understand these important aspect of what is green building, slowly and steadily, as now if you look at it, so many developers of the commercial building have started with the beam or with digital twinning of the building to reduce the maintenance cost. So slowly and steadily it's showing a upward curve towards these newer technology, and very soon you youngsters are going to implement this. And that's where I think it's very important that all of you should be aware of all these new technologies. And um, I'm looking forward you all to convince your clients to get into all this. So I have hopes that slowly and steadily we are going to look at this optimistic, futuristic building happening in Mumbai. Of course, there are so many people are talking about the net zero, zero carbon, and zero water energy. So slowly and steadily, we have to look forward to all these technologies. So very soon, decade back, even I was not aware that so many buildings are going for green building, IGBC, Griha, and all that. But you can see that they are now very popular. So there is a bright future. That's it from my end.
Right. Very true. Very true. Yeah.
Hi,
Vinit sir, you
Meenal.
want to? Yeah.
Yeah,
Vinit
yeah.
sir, you
Yeah,
want to
hi
add?
Vineet.
Long time, but I guess our association is not losing out in any manner. I guess she being our master's faculty in environmental architecture course, and she still continues in a similar manner, but on another platform. So, but the association is not being kind of going away. So that is a wonderful thing, and it is always a pleasure to listen to Meenal. How open-ended she makes these kind of lectures. It's always that is a perspective she always gives, which is uh, 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 which is creating an inquiry. It is not a thing which somebody gives you to believe and to take it for granted. It's always a kind of questioning mind which she opens out for all the people. And that's what is important under a learning platform, that you create another inquiry. You start making them to believe certain things, but at the same time, there is another question which opens out. And I guess rightfully, as she said, that you have to dream. I guess dream in a right manner, and dream with the right kind of knowledge behind you, so that you are going to be creating a dream which is more or less possible in a near future, rather than waiting for it to happen by somebody else. So it's important that to have such kind of lectures, rather I would say the kind of discussions in that manner, so that we are more responsible, as what she says is, and then trying to do a holistic approach towards the design. Because this is what I always been saying to the students also, when it comes to a design. I guess what we have somehow became a very linear design process oriented people, which was not the case earlier. We were more integrated design professionals, where that is why we've been called as a captain. I'm not saying the specialization has become intense and that is why people are trying to become linear, but it doesn't mean that you have to address in the same manner. You can always know certain things, get aware of the certain things, and be comprehensive in your approach. I guess that approach is very important. Then these specialized teams are going to be kind of contributing towards that particular goal you decide, which is very informative. So I guess this is very wonderful. I guess students are more I guess they must have got so many questions. They must have questioning themselves whether whatever I've done up till now or how I want to do it from here onwards is the kind of question they must be asking. So it's a very good thing. And I always say that the confusing mind is a very good mind, because that is how you start questioning lots of things, and that is why you start seeking answers. Because many times when you see certain things which are very clear, I guess that is not a right thing, because that makes you very complacent enough to innovate further than that. So the confused mind is always a good mind, I always say, and that is how there are lots of learning which can happen and which can inform lots of other people. Like many times, as what we say is these confusions of the students, confusions of the professional and the peer will makes us think and learn better, because unless in that situation is created, then only their innovation will happen. Otherwise everything will be stagnant and people will accept everything and will not want to go further in that. So this is the quality which you always bring, that you create that openness, you create that inquiry, and that is what everybody should be looking forward to. And thank you very much to be part of this knowledge series lecture and share your experience.
Thank you so much. Thank you. Yeah, Vineet is right. I think that's something as a passionate academician, a fellow peer, I would always do is give no straight answers. Sometimes it frustrates the students that, but tell us what to do. I was like, you'll figure out what to do. There is enough information available for you to know what to do. The question is not what to do. The question is why you need to do it. And that inquiry is very important. The sense of validation is very important. The better that understanding, the better will be your project resolution, because fewer will be the problems resolved. You would have anticipated, you would have completed your thinking. Like you said, your thinking becomes circular, your thinking becomes whole, and that is what is needed, rather than short-term thinking that I want to achieve this and I want to achieve that. So that's what we've always hoped for, and we wish to motivate, because these are the generations for tomorrow. These are students that's going to create the world of tomorrow. They are going to be professionals of tomorrow. We can only hope and aspire and inspire and motivate them, to think and to innovate, to disrupt, to question, to go against the flow. If you have to be brave, guys, it's okay. Dream, fight against the current if you believe in it. But your belief system has to come from very strong foundations, I feel. And that's actually also a very radical change in education right now, from what I'm seeing now versus what it was probably 15 years ago or 10 years ago. So I'm always, always there, please, to help students out or help them in whatever way they would like me to. So thank you for the opportunity from letting me be a part of this.
Meenal, it was brilliant. Meenal, it was really brilliant, and enjoyed along with the students, and lovely.
Thank you so much. Okay, so I think students are quite zapped, and yeah, they are like, which end to catch, we don't know. So what I'm going to do, guys, is I'm going to make the lecture content available to Parikshit sir. He will kind of hand it out to you, those of you who would like to go through it again, to scratch your heads and think about what is it that we were talking about, because there are multiple. I know I've kind of gone into multiple dimensions and multiple levels, and between history, present, future, we've done a lot of visiting there. So I will definitely have that available to Parikshit, and yeah, if there is anything I can do to help you all out at a later stage, let me know. But otherwise, all the best. Keep the good work on. Stay inspired and keep inspiring us back. Thank you.
Thank you.
Thank
Thank
you.
you. Thank you.
Thank you
Thank you,
so much.
Anuja ma'am. Thank you, Vinit sir. Thank you, Devang sir. I think
Gauri?
Devang sir. Gauri sir, I think he is not there.
Okay.
Yeah. Okay. Thank you. Thanks everyone for participating.
Bye.
Bye bye.
Bye bye.